Hi, this is Ms. Jensen, and today we are talking about law of sines. I can solve a triangle using law of sines and find the area with using formulas that are related to law of sines. Okay, so law of sines is just a ratio. So here you see, pardon me, it's a proportion. We use three ratios here. Usually we just do two at a time. It's just angle over opposite side equals angle over opposite side. But all three of those ratios are equal. So we use it when we're given an angle and an opposite side, and usually when it's not a right triangle, because we already know how to solve those. So if I'm given this triangle here, I'm going to start by just quick drawing a triangle. I'm not going to be too picky about it being proportional. I just really want to know what sides are opposite what angles. So I look at this and I need to look for an angle and an opposite side. So 29 is opposite 22, and I'm looking for M, and angle 112 is opposite that. So I'm going to go angle over opposite side equals angle over opposite side. Okay? So I'll go sine, doesn't really matter which one I do first. I'll do sine of 112 over M. As long as I have an angle over at opposite sides, that those are together, and I do sine of 29, that angle over its opposite side. And then I'm going to cross multiply. Okay. We'll divide both sides by sine of 29. And then we can put it in the calculator. So this is just kind of a reminder with putting it in the calculator, is you want to make sure that, I think I'll take out that parentheses. You want to put the parentheses, because it'll come up this way in the calculator. You either want to close those parentheses or you want to hit enter after you do the top. So 22 times sin 112, hit enter, divided by sin of 29, hit enter, and you should get your side. Round it to the nearest tenth. Okay? So that's law of sines. We're going to do one where we're solving the triangle. So we're finding the whole triangle. So what it means to find the whole triangle is all angles, all sides. You usually use law of sides twice for this, and sum equals 180. Okay, so once again, we're going to start out by quick sketching a triangle. I'm not going to worry too much about what it looks like. This is 33, this is 105, opposite B is 37.5. Okay, I just want to know what's opposite what. So I need to find side A, side C, and angle C. Well, because I have an angle and an opposite side, I can use law of sines. So I'm going to go angle, so I'll go sine of angle 105 over its opposite side, and sine of 33 over its opposite side. So just put an A here. And I'm going to cross multiply just like I did before. I'm going to cross multiply just like I did before. I won't do all those steps just for kind of the sake of time. But we should end up with 21.4 when we do that. Okay, I just want to note something because this will come up in the next section that we're doing on law of cosines, but one of the problems here doesn't show it. If we were looking for a missing angle using law of sines, we would still do the same ratio. It's just that we would end up with something like this, where we would end up with, for example, sine of A is some funny decimal like that. So I just want to mention, if you're looking for an angle, you have to do second sign to find it. So that might come up in your homework. And then whatever your answer is, that would be your angle. Okay? I'm going to erase that just because doesn't have anything to do with that problem. But if you are looking for an angle, that's how you would go about doing it. Okay, I think it's going to come up more in the next section, but I just wanted to mention it just in case. So we found side A, okay? Now I need to find, well, I guess side C, but the problem with side C is I don't have an angle. That's pretty easy to solve because I can go 180 minus 105 minus 33, and angle C ends up being 42. So that's easy enough. Now the only side I need to find is side C. So I could either use 33 over 21.4, or I could use the same one I used the first time, which is 105 over its opposite side of 39.9. But now, since I'm looking for C, I have to go sine of 42 over C. So again, we're going angle over side equals angle over side. We'll cross multiply. So I end up doing 37.9 times sine of 42. Hit enter, divide by sine of 105. And C should be 26.3. Okay? So that's law of cosines. Now, we've got two formulas to find area. So the first one is when we're given two sides and an angle. Okay, so notice we use sine to find this missing area. So normally area is base times height. Well, in this case, we don't have a base and a height, or we're not going to in these cases. So if I'm given two sides and an angle in between, I can use this formula to find it. I'm just going to pop to the example and then we'll look at the second formula. So, again, I think it's kind of nice to draw a picture just so I can see what's going on. Boy, a lot of 12s here for whatever reason. Now, if I were going to pick a formula, I'm looking for I'm looking for the area, but if I'm looking at what angle I'm given here, and I want to match it to a formula, that's the angle I'm given is A. So if I follow the formula that goes with this, that's what it's going to look like. So if I'm punching this into the calculator, I usually just kind of think about, okay, what's the angle? The angle goes here. So instead of worrying about A, B, C, that's the angle. The other two sides doesn't matter what order, especially when it's 12 and 12, but you're going to put it there. Okay? Then you can just punch the whole thing as is. So you can go 0.5 times 12 times 12 times sin of 12. Okay? And that's unit squared. So that would be the area of that triangle. Now, there's some calculators where you might have to do a little bit different order. Like if you're doing it on your computer, you might have to do 12 sin, hit enter, times 12, times 12, times 0.5. But most scientific calculators and graphing calculators will just let you put it in as is. Okay, so this one, here we have 3 angles. So we're going to use this formula. So if we're given 2 angles and a side, pardon me, that's what we were given on the last one, 2 angles and a side, we can easily find the third angle by going 180. So one thing to notice here is whatever side we're given, the angle goes in the denominator. Side B, angle B goes in the denominator. Side C, angle C goes in the denominator. So that's the thing I want you to keep in mind. do this problem. All right, so again, it's just kind of nice to see what we have here. Side A is 45.7. We're just looking for the area. Okay, so this is half. So if we want to slap a formula with this, remember we said whatever side is given, we put the angle opposite in the denominator. So because angle A, which is 27, is across from 45.7, A goes on the bottom, A goes here. This is B, it should be capital B. This is B, this is C. So if we like the formula, I usually don't worry too much about the formula. We have to remember this one, sin over sin, and the squared. But otherwise, I just worry about, okay, what's my angle on an opposite side? I put the side given here, the angle opposite in the denominator. And then the two remaining angles, of course I have to figure out the last one, which is easy. 180 minus 111 minus 27 is 42. Okay, so those other two angles of 111 and 42 go here. And then you put it into your calculator. So 0.5 times 45.7 squared times sin of 11, I would hit enter, times sin of 42, hit enter, divide by sin of 27, hit enter. So make sure you either close those parentheses when you put it in your calculator or hit enter. But we end up with 661.4 units squared. Okay, so that is log sines. So log sines we use when we don't have a right triangle and we're given an angle on a side. So we can use that to find any missing sides, any missing angles. These area formulas are based on log sines. The first situation is if you're given two sides and an angle in between. And the second situation is if you're given three angles more or less and one of the sides. Okay, that's it for today.